big quizzes, I just wanted to do a quick overview of what is on your test. When's your test? Wednesday. In a while. Did you just say in a while? Yeah. Your test is in a while. If a while means 48 hours from now, then yes. Yep. Okay. So, what is on the test? Number 1, a lot of antiderivatives, a lot of U substitution. So make sure you are comfortable with U substitution and antiderivatives. Riemann sums and trapezoids, both. There will be trapezoids, there will be rectangles. You need to be able to approximate integrals using rectangles and trapezoids. You do not need a cell phone right now. Okay. Number 3, exact area using limits, setup only. So just like on your big quiz, all we checked for was can you set it up? We did not make you sit there and evaluate that whole thing. Same thing on your test. We're just checking to make sure you know how to set it up.
Hey,
yeah.
Okay, that's progress.
There we go. Huh? Okay. Yeah, you're welcome. All right. Number 4, definite integrals, or in other words, FTC Part 2, including integrals of piecewise functions and U substitution with a change of limits on a definite integral. So if you have not done the Chapter 5 review assignment in WebAssign, which is optional, but strongly suggested, there is a nice, simple, definite integral of a piecewise function in there that I would make sure I could do prior to Wednesday. Okay. FTC Part 1. What is FTC Part 1? That's a derivative of an integral with variables in the limits. Plug the top limit in times its derivative minus plug the bottom limit in times its derivative. That will be on your test in multiple places. So you really need to be able to do that. There is one problem with multiple parts that is dependent on you knowing FTC Part 1. So if you don't know FTC Part 1, you can plan on your grade probably dropping by a whole letter. It's a big part of your test. All right, same thing. U sub's bigger, but FTC Part 1 is still big. All right. PVA, huge part of your test is PVA. On your big quiz, the PVA was only a couple of parts. On your test, it's like a whole page. It's like 25 parts. It's not, but it's a lot of parts, okay? So PVA, you have to know everything that you've ever learned about PVA. So if we give you velocity, you have to be able to find acceleration, you have to be able to find position, you have to be able to find distance traveled, displacement, when is the particle at rest, when does the particle change direction, when is it moving to the right or the left, right? All those things are fair game for this test. If it's ever been on a test, it's fair game again, right? Which is why, yes, our old friend IVT showed up, right? Isn't it good to see old friends? Yes. Okay. Okay. All right. And then finally, meaning of an integral. So some kind of a problem where the words explain the meaning are in there. There will be at least one problem that has an integral in it where you have to explain a meaning. The main thing I can teach you about this is remember that the definite integral of a rate gives you the net change in the amount. The definite integral of a rate gives you the net change in the amount. It's the amount at one endpoint minus the amount at the other endpoint. It's the amount, the total amount, change in the amount. So if the integral is the number of people that entered a rate at which people are entering an amusement park, then the definite integral of that rate would be how many people entered the amusement park. Okay, so definite integral of a rate gives you an amount. Yeah. The limit definition of an integral? Yeah, that's this right here.
Oh.
Yeah. Good. Any other questions before we move into your big quiz? All right, so what I have for your big quiz today is I have a whole ton of slides. First, so for each problem, I have a slide with the problem, and then I have a slide right after it with a similar problem for you guys to practice with. So you're going to need paper and pencil. Because no one in any class got a 10. So everybody has room to improve. A student. I had 1. I don't know. Miss Grunwald might have 10s. I'm just speaking for my own student. All right, so this first problem, we have a sine and a cosine. When you have a sine and a cosine, your u can go either way. It could be sine, it could be cosine. So how do we know which one to pick for our u? Yes, yes, the one with the exponent on it. So your u for this has to be cosine x. What's the derivative of cosine? Negative sine. Those positives and negatives cost you guys a lot of points. So you've got to be so careful with your positives and negatives. All right? Okay, so your u is cosine, your du is negative sine. I personally like to make it look like it's supposed to look, so I multiply both sides by -3. So some of you guys are literally, you're doing a u sub, you're writing u as cosine, and then you're just jumping in and starting to throw stuff on an integral symbol and hoping it works, right? You can't just write a u and then jump to the integral and just throw stuff down and hope it's right. You really do have to find your du, write it properly with the dx, right? And then, like, what I do personally is when I'm teaching, I underline. When I'm doing it myself, I literally am mentally kind of doing the underline. I don't usually actually underline, but sometimes I do. It's really complicated. But I underline as I go. So cosine to the 7th, that's now u to the 7th, right? So my cosine to the 7th becomes u to the 7th, and then whatever's left, 3 sine x dx, I look and I say, oh, here's 3 sine x dx. What do I need to replace that with? I replace it with a -3 du. So my cosine x to the 7th becomes u to the 7th, and then 3 sine x dx becomes -3 du. All right, and then you just anti-differentiate. So -3a u to the 8th plus c, and please don't forget to go back to x's. Some of you lost points. You got all your u sub right and didn't convert back to x's. So these, just, your big quiz, that's all or nothing. I don't give partial credit on a big quiz. It just takes too long to grade. So if you made even a tiny mistake, you lost the point. Every single problem was just a point. So you got a 0 or a 1. All right. Are you ready to try one? Here you go. Give it a shot. All right, what's your u? Sine. Notice the u doesn't have to encompass like the entire thing. It doesn't have to be sine cubed. It can just be sine. The exponent's okay. We can have exponents like left over. All we have to do is make sure we get rid of the x's, really. So, all right, so our u, whoop, there it is. Our u is sine, our du is cosine. Oh, my integral got cut off. There we go. So we have the integral of u to the -3rd du, which is -1/2 u to the -2nd plus c, which is -1 or 2 over 2 sine squared x plus c. Any questions? We're all okay? Okay. All right, good. Next one. For this one, your u cannot be cosine? Why can your u not be cosine? Because you don't have a sine, right? If your u was cosine, you'd have a du of a sine, and how are you going to, you have no sine there to replace with a du, right? You have to have the derivative of whatever you're writing in there somewhere, in some form or fashion. So the u cannot be cosine. So what would the u be then if it's not cosine of x cubed? Just the x cubed. Your u is just the x cubed. So your du would be 3x squared dx. So I personally took like the -3 and the 5 and kind of put them together and called them -15. So I made mine so that it looked like -15. So I think I did it up here too. So I rewrote that as -15 x squared cosine x cubed dx. So my u is x cubed. My du is 3x squared dx. Multiply both sides by -5 to get the -15 x squared dx. So this becomes cosine u, and then this becomes -5 du. And so, oh, what is the antiderivative of cosine?
Wait, sine, but it's negative.
Okay, so the antiderivative of cosine is sine, right? So this becomes -5 sine u plus c, -5 sine x cubed plus c. Charles, how you doing? Good. Okay. You tired? Yeah. It's hard to come back after a break. All right. Okay, here's one to try. What's your u? X squared. So your du is 2x dx. Well, we have a 5x dx. So I'm going to divide by 2 and multiply by 5 to turn the 2 into a 5, right? So, let's go this way. Okay, so u is x squared, du is 2x dx, so 5 halves du equals 5x dx. So I replaced my x squared with the u, so I have secant squared u, and then 5x dx becomes 5 halves du. We end up with that. Oh, if only we knew the antiderivative of secant squared. What is it? It's tangent. 5 halves tan u plus c. Go back to x's. 5 halves tangent of x squared plus c.
Instead of multiplying 5 into that, could you just keep it as a coefficient?
So the question is, could we, when we start these problems, just move the 5 to the front? Absolutely. Some people like to do that. That's fine. Right? You can just throw the 5 in front of the integral, do the whole thing, and just multiply it at the end, and that's fine. All right. Next one. Another u sub. It's like we're trying to test you on it. What's up? What's your u? 3 minus 5x cubed. So your du would be -15 x squared dx. We don't want a -15, we want a 2. So I personally multiply both sides by -2/15 to turn the -15 into a 2. Divide by -15 times by 2. So that's what I do. If you want to pull the 2 in front, that's fine too. Okay, so this becomes root u, or u to the 1/2, and then the 2x squared dx becomes -2/15 du. Notice we don't have to have everything that's in the integral over in our u sub, right? We just need to get it down to something we can integrate. I can integrate u to the 1/2, right? It's 2/3 u to the 3/2. So we end up with I just went ahead and kept it separate. -2/15 times 2/3 u to the 3/2. So you end up with -4/45. Put your x's back in, 3 minus 5x cubed to the 3/2 plus c, or in radical form. This was fine. I accepted it with rational exponents or radical form. They're both fine. Any questions on this one? Ready to try one? All right. X to the 5th minus 2. So your du is 5x to the 4th dx. You're welcome. So you end up with just the cube root of u du. So you end up with, this is 3/4 u to the 4/3 plus c. And then you plug your x's back in. Rational exponents or radical form are both fine. Are you starting to feel a little more comfortable with u sum after doing 14 of them? All right, we still have more, but the next ones are a little different. Okay, e. Remember I told you that your u is usually your guts? It's still true with e. Now the guts of e to the x are the exponent on the e to the guts. So if you have an integral and it's e to the guts and the guts are not just x, like I can integrate e to the x, right? But I can't integrate e to the root x. I don't know what the antiderivative of e to the root x is. So I have to have my u be the exponents up here on the e because that's where the guts are. So whenever you have e to a power and that power isn't just x, 9 times out of 10, that power is going to be your u. All right, don't let it, and I always have students who try to think themselves out of solving the problem. They try to do everything in their head and they say, it's not going to work, it's not going to work, without writing anything down. Just write it. See what happens. Maybe it'll work, right? So let your u be root x because if your u is root x, well, the derivative of x to the 1/2, what's that? 1/2 x to the negative 1/2, or 1 over 2 root x, right? Dx. So, hey, look, this is 1 over root x dx. We have a 1 over 2 root x dx. You just have to move the 2 over. So 1 over root x dx is just equal to 2 du. Now, this one was extra fun because it was also a definite integral. So because it was a definite integral, you not only had to do your u substitution, you had to change your limits. So if x is 1, u is the square root of 1, which is 1. If x is 4, u is the square root of 4, which is 2. So our new integral is just the integral from 1 to 2 of 2e to the u du. Now this is a happy integral, right? What's the antiderivative of e to the u? E to the u, right? Derivative of e to the u is e to the u, antiderivative of e to the u is e to the u. So antiderivative of 2e to the u is 2e to the u from 1 to 2. That sounds like a limerick. So odd. And then you just plug in and you get 2e squared minus 2e to the first. Okey-doke. All right, you ready to try one? Okay, what is your u? Cotangent x. So the derivative of cotangent is negative cosecant squared x dx, right? So I'm going to move the negative over. Cosecant is the same thing as 1 over sine. So this is 1 over sine squared x. Look at that. It's like perfect, right? So what have we got? When we rewrite our integral, so we have negative e to the u du. Pretty nice integrand. So now we've got to change our limits. Cotangent of pi fourths, well, that's just the reciprocal of the tangent of pi fourths. Anyone know the tangent of pi fourths? It's 1. So its reciprocal is just 1. All right. Cotangent of 3 pi fourths, well, that's the reciprocal of tangent of 3 pi fourths. Anyone know the tangent of 3 pi fourths? Negative 1, second quadrant. Tangent is negative, so cotangent is also negative. Hey! Oh no, we're high to low. When we have our limits going high to low, how could we flip them? Oh, doesn't look at how that works out, right? Oh my goodness, it's just like magic. We get this like really nice happy integral now with no negatives and easy limits, right? Okay. What's the antiderivative of e to the u? E to the u from -1 to 1, so we get e minus 1 over e, or e minus e to the negative first. Kind of fun, right?
Oh yeah.
See, it's not bad. All right, any questions?
What was the easy one that you said you did?
I did it similar. I did like an e to the sine times cosine. It was too easy. Yeah. I wanted to add some harder trig in. So.
Well, you did.
I did. Yes, I did. Okay, next one. U substitution. What's your u? It's x plus 3. It's the guts, right? It's almost always the guts. Your u is x plus 3. Your du is just dx. We have a problem. Because if the u is x plus 3, well, I can rewrite that. That's u to the -1/2. And dx, that's just du. That's easy. But I'm still left with this 2x minus 1. Right? So what do I do? Now, I got to be honest, what I did over here, I think I'm going to do it a different way. So, okay, so here's u. Here's du. We still have x's left, right? This is a special case u sub. So I have to solve for x. X equals u minus 3. Now, I think what I would do if I were doing this over again, which I am, so I might as well do it, is I would write it, whoop, I'm writing it with the marker upside down. Okay, I would write it like this. So bottom, that's u to the 1/2. Okay, this is du. And then I would just put 2 times what is x, u minus 3 minus 1, and then clean it up. Okay, so whatever. So anyway. All right, so either way, so we get it, however you get it, this ends up equaling 2u minus 7, right? Now, I put the u to the -1/2 up. I could have kept it down and divided, or I could put it up and multiply. Either way, you have to put them together because you can't do an integral of a product or a quotient unless it's a known product and quotient like secant tangent. But apart from that, you can't do an integral of a product or a quotient. You got to put them together. So we either keep it down below and divide every term by u to the 1/2, or we bring it up and multiply every term by u to the -1/2. Either way, it's potato, potato. So when we multiply it in, we get 2u to the 1/2 minus 7u to the -1/2 du, and then you just do your normal integral. So you have 2 times 2/3 u to the 3/2, which is 4/3 u to the 3/2, minus, and then this is 2u to the 1/2, so minus 14u to the 1/2 plus c, and then you put your x's back in. And you're left with that lovely thing, which actually many of you got. Like, that was actually one of the least missed problems on the quiz. You guys missed like the easy ones and got this really complicated special case u sub problem correct overall. So anyway,
Okay.
all right. Any questions on this? You ready to try one yourselves?
Oh yeah, let's try.
Okay. Mihika, can you see okay?
Yeah.
Okay. All right. All right, this one, there will be fractions. Yay is right, right? Fractions. So your u is 3x minus 5. Your du is 3dx, so 1/3 du equals dx. So that takes care of the bottom and the dx. But we still have the x plus 2, so you have to solve. So you get x equals u plus 5 over 3, or 1/3 times u plus 5. I went ahead and just wrote the plus 2 over here. 1/3 times u plus 5 plus 2. All right, so rewriting my integral, I get 1/3 du, that's my dx. The u goes on the bottom, and then x plus 2 equals 1/3 u plus 5 plus 2. All right, you cannot pull this third out yet because it's not in every term, right? So algebraically, you've got to combine first before you can pull a third out. So that's why I was saying you can't just start like see a fraction, get rid of a fraction, because you could if you pulled like truly divided the 2 by the 1/3, right? But anyway, I just combined first. So I went ahead and combined my fractions and got 1/3 times 1/3 u plus 11/3 over u, and then I went ahead and pulled the 1/3 out. You don't have to, but I did. So you have 1/3 times another third times u plus 11 over u.
Wait,
That's where I am.
So, what do I have to do in order to hit it? Oh, yes, Faith.
Are you allowed to just combine like terms, so but make it 6/3 and
Yeah, 2 is 6/3 plus 5/3 is 11/3.
okay.
That's what I did.
Is it not?
What's negative?
Wait, yeah, it's negative, so it's 1/3.
I truly don't know what you're talking about. What's negative?
So it's like 3x minus 5, so then the x would be 1/3 u minus 5/3.
No, you add 5. U is 3x minus 5, so x is u plus 5 over 3.
You have a negative.
But you have a negative
symbol.
I do?
Yeah, and just in the first one.
Oh, I'm sorry.
It works out anyway.
There we go.
so that she has a
It was just me miswriting. Oh, thank you. Okay, there we go. Is that what was throwing you guys? Okay. So anyway, what do I have to do from here? I got to divide, right?
Or multiply by n.
Okay, or multiply by u negative first. So you end up with 1/9 times 1 plus 11u to the negative first, or 11 over u. What is the antiderivative of 1 du?
ln absolute value.
What is the antiderivative of 1 du? 1 du. It's u. So be careful that your antiderivative of a constant is the constant times this variable, not x, u. Big difference, right? You're in du world. Everything's u. So the antiderivative of 1 is u. Okay, now it's your turn. What is the antiderivative of 1 over u?
ln absolute value.
ln absolute u, right? So you end up with 1/9 times u plus 11 ln absolute u plus c. Then you got to put your u's back, or your x's back in. So you get 1/9 times 3x minus 5 plus 11 ln absolute 3x minus 5 plus c. I have more. Now the reason I have more is to teach you a little caution about the AP exam. I love that we did this problem, and this is just something I made up in my head first period, and it just worked out so beautifully. So if you were doing this whole thing, now 99% chance this would be a multiple choice problem on the AP exam. So if you're doing this and it's a multiple choice question, and you get here, this would not be one of the answer choices. This would be the answer choice. Why would this be the correct answer choice and not that? Yes.
Because you can just put the 5 in the C.
Yes. The College Board will never have constants with a plus C. They will lump every constant into the plus C. So they will never have 3x minus 5 plus 11 blah, 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 plus c. The 5 will get thrown in with the c. And so when you're looking at your answer, you'll be like, gosh, everything was there except the minus 5. It's because they took the 5 and put it in with the c. So just a little warning. This is fine. Like if you're taking your test, this is beautiful. I love it. It's great. But just warning you, multiple choice college board, this is what you're going to see. Oh, the hands are up. Yes, Ari.
Wait, so how did you get the -5 to go with the C?
Because it's just a constant, like you can distribute in the 1/9, and then you just have, 1/3 x minus 5/9 plus -5/9 plus c is c. Constant plus a constant is a constant.
Oh.
Right? Yeah.
Why wouldn't you take it out of the
Ooh, because is that the same? Is this ln 3x minus ln 5? Right? This you can't, it's attached. Yeah, you can't change the argument of the log without changing the actual answer. Yeah. There's no way, let me say it this way. There's no way you can add or subtract a c that creates a horizontal shift on this function, right? And that's what that -5 is doing. Okay. Good talk. Moving on. Okay, which limit below gives you the exact area, whatever it says, of the region bounded by y equals 3 minus x squared from -1 to 1. This is memorizing. I'm not going to spend a lot of time on this. If you didn't get it, it just means you didn't memorize. So you got to memorize. So what are we memorizing? The limit as n approaches infinity of the sum as I goes from 1 to n of width times f of left endpoint plus width times I. It's a big, long formula that you have to just know, unless you want to derive it from scratch on your test, which I don't think you want to do. So just remember, so this is me writing it out. The limit as n approaches infinity, sum as I goes from 1 to n, width is, I have it down here. Okay, width is b minus a over n, right? So it's 2 over n. So width times f of. So you write your function, 3 minus x squared, and just put a big parenthesis where the x is. What goes in that parenthesis? Left endpoint plus width times I. Left endpoint plus width times I. So just remember, it's width times height. It's an infinite sum of rectangles, right? Width times heights. So how do you find the heights? It's the function evaluated at left endpoint plus width times height. All right, so that's all we're going to do with that. Most of you guys got that. So vast majority of you got it. If you didn't, you just need to look it up and learn it. Yes?
Are we going to have to solve those on our test?
Nope. That's why, remember first thing I said when we did that opening, and I said, here's what's on your test? I specifically said, you only have to set it up. All right. So we're not going to do practice because I'm not going to practice memorizing. You can memorize. All right. So differential equation. Here we go. Find the solution of the differential equation f double prime equals 6 times x minus 1, whose graph passes through the point 2, 1, and at that point is tangent to the line 3x minus y equals 5. So we're starting with an f double prime. First of all, a solution to a differential equation means the original function. Some of you guys gave me like x equals 12. It's just nonsense, right? That doesn't even make any sense. So no, you're not solving for x, you're solving for a function. So the solution to a differential equation is the original function, f of x. So, which we've done, you've just forgotten. So it's been a couple of weeks, right? So I get that. We need information to find the unknown constants. So you need information about f prime and you need information about f. Lucky for us, they gave us the equation of the tangent line, which I went ahead and solved for y. So you get y equals 3x minus 5. What does a derivative give you? Slope of the tangent, right? Slope of the tangent. So what this says is, at the point 2, 1, the slope of the tangent is 3. In other words, f prime of 2 equals 3. f prime of 2 equals 3, and then f of 2 equals 1. So there's our f double prime, which I distributed the 6 because I like that. So there's my f prime, just anti-differentiating with a plus c. F prime of 2 equals 3 we get from our tangent line. Plug a 2 in, set it equal to 3, solve for c, and you get c equals 3. So then you rewrite your f prime, just ignore those words on the side. So you get 3x squared minus 6x plus 3, that's f prime. Anti-differentiate again. Remember, you can't reuse c, so I called it k. You could use subscripts. And now we know f of 2 equals 1, so plug in a 2, set it equal to 1. Solve for k, you get k equals negative 1. And your final answer is x cubed minus 3x squared plus 3x minus 1. I think these are fun. I like doing these. However, it's not on your test. So it's one less thing to study. It will show up on a test. The whole chapter 9 is all called differential equations. So you will be doing lots of differential equations in chapter 9, which is the last unit of this term. Don't think it's a BC, it's an AB. It's just in chapter 9. So you will be doing these. It's just not on this test. We had to do so much already that we just couldn't include it. So we're not going to practice that either because it's not on your test. This is on your test. The only reason, so this is easy. If you didn't get it, you just forgot it. That's all. Or didn't recognize it. So that's what we need to practice right now, is making sure you can get this, because this is on your test in multiple questions. You have to know this. What is this? When you have a derivative of an integral with variables and the limits, this is FTC part 1. Plug in the top limit times its derivative minus plug in the bottom limit times its derivative. It's easy if you remember it and recognize it, right? Okay. So what do? So we want a derivative of an integral with variables and limits. Take this 3x squared and plug it in for t times the derivative of 3x squared, which is 6x. Minus, take the 4, plug it in for t times the derivative of 4, which is 0. All constants go to 0 when you're doing FTC part 1. So you end up with, this is plugging in the 3x squared times the derivative of 3x squared, which is 6x minus 0. So if you clean it up, you get 108x to the 5th minus 54x cubed. Which you can factor GCF out if you want to. I don't care. This was actually acceptable, right?
You just say 0.
Yeah, you can just say 0 for this.
Okay.
Yeah, absolutely. You have to know FTC part 1. You have to know it. And you have to be able to recognize it. And you have to know it. Because I might give you a function that can't be integrated. Haha. Right? And so the only way to do it is FTC part 1. All right. So I wrote FTC part 1 down here just in case you don't have it in your notes. Isn't that beautiful? It looks so scary, but it's really not that scary. Just plug in the top limit times its derivative minus plug in the bottom limit times its derivative. Okay. Yeah.
I was gonna ask, so you know it's FTC part 1 when there's like an exponent?
When you have a derivative of an integral with variables in the limits. That's how you know. That is how you know. FTC part 1, derivative of an integral with variables in the limits. You guys already have this in your notes. I don't know if you're rewriting. I see a lot of people copying, but it's in your notes. Okay. All right, you ready to try one? Here we go. Give it a shot. This function has an antiderivative, but it requires a concept called trig substitution, which you have not learned yet, so you can't anti-differentiate it. Don't even try. You should be done. Like, it shouldn't take that long. It's just the amount of time to copy the problem and write the answer. There will never be t's in your answer. The answer will always be in terms of whatever variables in the limits, right? Because that's what you're plugging in. All right, questions on this? Brian, you okay? You look mad. Okay. All right, let's move into applications. I'm going to skip that one. Okay, the train. A train runs back and forth on an east-west section of railroad track. Its velocity, measured in meters per minute, is given by a differentiable function v of t, where t is measured in minutes. Selected values for v of t are given in the table above. It used to say to the right, and now it says above. Okay. Part A, find the average acceleration from 2 to 8. Average acceleration, that's an average rate of change of the velocity. So it's v of 8 minus v of 2 over 8 minus 2. Most of you guys got this one, so I was real pleased. I have one little thing to warn you about. So the answer was negative 110 over 3 if you reduce the fraction. Did it ask for units? Did it say include units with the answer?
No.
No. Should you give units if it doesn't ask for units? No. Because at least one, and I think maybe 2 or 3 students lost this point because they gave me wrong units. So be very careful. If you give units and they're not asked for and your units are wrong, you still lose the point. Don't give units if I don't ask for units. Okay? All right. So any questions on average rate of change? No, we're all good. Good. Okay. All right, good. Next question. Do the data in the table support the conclusion? This is grammatically correct. Support the conclusion that the train's velocity is negative 100 at some time from 5 to 8. Give a reason. Do the data? Yes, the data do support the conclusion. Okay. So, data is plural, datum is singular, right? Okay. Yes, multiple datums. Do the multiple datums support the conclusion? Yes. Okay. All right. So, we want to know if this negative 100 is going to fall as a velocity value between 5 and 8. So, we're looking for a value on our table. What theorem is that to know if there's a value like in between two values on your table? That's IVT, right? What's the first thing we always write when we do IVT? Continuous. All right. So this whole problem was worth a point, but I looked for 3 things. Number 1, did you state that the velocity function was continuous? Hopefully on the closed interval from 5 to 8, but at least did you just say it was continuous? Because they said it was differentiable, therefore continuous, right? Okay, so you had to state v of t was continuous. The next thing I looked for, did you show that negative 100 fell between v of 5 and v of 8. And watch out, because v of 5 was higher, v of 8 was lower, and some of you guys wrote your inequalities backwards. So, got to be careful. So, you got v of 5 is actually greater than negative 100, which is greater than v of 8. And then it's good to write the numbers. Once in a while, you'll hit a College Board problem where they, like if you write it with function values and you don't state what the function values are, they don't give you the credit. So, like you could write off to the side, like v of 5 equals 40, v of 8 equals negative 20, but somewhere you should equate your function values to it. But anyway, but make sure that your arrows are pointing in the right direction. And then the third thing I was looking for was IVT, right? So yes, by the IVT, the data do support the conclusion that the velocity will be negative 100 somewhere in the interval between 5 and 8. Okay. At time 2, the train's position is 300 meters east of origin station. That's a positive 300. I don't know if you know, like, make sure you know north, south, east, west, positive 300. Okay. All right. And the train is moving east. Write an expression involving an integral that gives the position of the train in meters from origin station at time 12. You don't evaluate this integral. It just says write it, right? So I wrote this over here on the board just so you could kind of see the thought process. Some people like know this and just could go right to this. Some people had to start here. That's fine. Like any of this makes me happy, right? But just know the integral from 2 to 12 of velocity, well, what's the antiderivative of velocity? Position. So this would be the position at 12 minus the position at 2, right? We want the position at 12. So if you solve for p of 12, you're just adding p of 2 to both sides. P of 12 equals p of 2 plus the integral from 2 to 12 of v of t. And I want you to think ending position equals starting position plus the net change in the position, right? Ending amount equals starting amount plus the net change in the amount. Right? It's not just with PVA. This works with anything. So ending amount equals starting amount plus the net change. So net change is the integral of the rate. So, and then just substitute 300 for p of 2. So don't, like that's for the next part. That was me just commenting on the next part. So anyway, there's a lot of like machine-mashy stuff on here. But I accepted like any equation that's equivalent to correct is correct. But I do want the 300 substituted in for p of 2. So please, like if they give you a numeric value, please put it in. So otherwise, you know, it's not really an equation that you could solve for. So something where you either have it this way, this would be totally fine. Integral from 2 to 12 of velocity equals p of 12 minus 300. That's fine. This is full credit. P of 12 equals 300 plus net change. That's full credit, right? Anything that's equivalent is fine. I'm going to outline this too. This is fine too. Okay. All right. So anyway. Now we have to evaluate it. How are we going to evaluate it? Well, they want us to use trapezoids. So we have to do a trapezoidal sum with 3 subintervals going from 2 to 12, starting at 2, ending at 12. Trapezoidal sums do not give you the position at time 12. A trapezoidal sum is an approximation of a definite integral. So this is what's approximated by your trapezoids. Whatever you get, you still have to add 300 to get the position. So the integral is approximated by your trapezoids, and then whatever you have to add to it. Be careful. Let's look at the table. We're going from 2 to 12. Are the intervals equally spaced? No. The first width is 3. The second width is 3. The third width is 4. You had to do each trapezoid separately. So you can pull the half out, right? So there's the 300 plus. So pull the half out, and then this is like me just showing the setup. 3 times the sum of the heights, plus 3 times the sum of the heights, plus 4 times the sum of the heights. And then you add it all together. You had a calculator. Just so you know, this was negative 450 plus 300 gives you negative 150. So you could really, if you wanted to write it nicely, you would say at t equals 12, the train is 150 meters west or west of origin station. This was an AP problem. In case you're wondering. All right. Moving on. PVA. Your PVA on your quiz was very short. PVA on your test is huge. It's huge. Whoa, the hands are up. Yes, Ari.
Don't we have number 10?
Whoops. Oh, it's just misnumbered. Sorry. 10. There you go. Okay. Emma, was that your question?
Yes.
Oh, okay, yeah. It's because I rearranged things this year to give you more space. Last year I did the whole quiz on 3 sheets of paper, and this year I spread it out a little bit. You got 4 sheets, like front and back, so just to give you a little more space. So anyway, so 11 became 10 because I moved things around, and 9 became 11. So anyway. All right, so you have the velocity function given by v of t equals sine t plus 2 to the t from 0 to 5. I personally would suggest if I have a velocity function and I have a calculator and there's like 8 parts to the problem, which there might be, I personally, even on an 89, would still put the velocity in y1, graph it, and do everything on the graph window. First set your window 0 to 5, right? Don't let, like, if you have an interval, make that be your window, right? Don't go, negative 10 to 10, because then you'll be looking at velocities all over the place that you don't want to see. All right, acceleration at time 3. So if I'm on my calculator, I just do second calc, dy dx, 3, enter, and I get the acceleration. Not much to it. So acceleration is the derivative of velocity, should be 4.555. By the way, how many decimals are you required to put? 3. I could not believe how many of you gave me 2 decimals. I just couldn't believe. There were like 10 students who lost points for only giving me 2 decimals. I had one of you who on one problem gave me an exact answer. I don't remember which one it was. It might have been the train one, like the 110 over 3 or whatever. I don't know what that equals. What is it? Let's see. 110 over 3. And then they wrote like or. So what is it? Negative 36.33 and then stopped. Now, this was fine, but I tell you now, I have to take the last answer, and the College Board does too. If you write a final answer and then put like equals and then put something else, this is what I grade. So you have to, like, I don't know why you're doing this. This is fun, right? It's exact. Well, I was going to take off on exact, right? So anyway, so I had a student who did this multiple times, didn't give me 3 decimals. By the way, a little warning, the College Board does not like this. Do not, I didn't take off, but please don't put a repeating bar over it. Oh my gosh, just write the 3 decimal places. It's not hard to write 3, right? It's really not. Give me the 3 decimal places. Do not put a repeating bar over a number. All right, that's enough lecture on that. Okay, distance, whoa, I hate that orange. Okay, distance traveled. You have to know this. Distance is the definite integral of the absolute value of the velocity. And I wanted to see it. Remember that we don't give you points for answers without correct setup, right? definite integral of the absolute value of the velocity. And by the way, the definite integral of the absolute value of the velocity is not the same as the absolute value of the definite integral. You can't just stick the absolute values anywhere. They have to be around the velocity function. So you have to know distance is the definite integral of the velocity. Displacement is just the integral of the velocity, right? So make sure you know distance versus displacement because they'll both be on your test. All right. And I was picky. No DT, no credit. We have to use good notation, right? We're good mathematicians. We use proper notation. We put our differentials with our integrals. Yep. Okay. All right. Good. Any questions? Did you all any questions on this or this? All right. Okay, we're going to do that in a minute. I want to finish this last problem first, and then we'll go back and do a PVA review. All right, last problem. Da, 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 da. This will be on your test. This is not this exact problem. Okay, so the graph of f shown to the right consists of 3 line segments. Let g be the function given by g of x equals the integral from -3 to x of f of t dt. Part A, find g of 3. Doesn't say g prime of 3. It says g of 3. G of x is this. This is your x. We're replacing the x with a 3. The 3 goes here. G of 3 is the integral from -3 to 3 of f of t dt. Okay, you're replacing the x with a 3. How do we find the integral from -3 to 3 of f of t dt? If this is the graph of f, there's -3, there's 3. It's the area of this triangle minus the area of this triangle. Okay? So, the big triangle had an area of 10. The little triangle had an area of 1. 10 minus 1 is 9. You did it, but just did it wrong.
I counted to 4.
You counted to 4?
Yeah, I counted from -5 to 4.
Oh, you did the whole thing.
Yeah.
Yeah. Okay. All right. Okay. So, that's that one. I'm going to erase this so you don't see it. Okay. Next part. On what interval from -5 to 4 is the graph of g both increasing and concave down? Give a reason for your answer. Well, how do we know when g is increasing? When g prime is positive, right? We need g prime. We don't have g prime. We have the graph of f, right? If you have a question about g and you're using f to justify, the first thing you have to have on your paper, and I didn't take off, but I wrote a little comment, you have to somehow relate f and g. You can't write f in your answer on a function about g unless you have related them somehow, right? We need g prime. We have g, we need g prime. What is g prime? Well, let's see. G prime, it's the derivative of an integral with variables in the limits. It's FTC part 1, right? So because of this, what do? We plug the top limit in times its derivative, which is just 1, minus plug the bottom limit in times its derivative, which is 0. So what is g prime equal? It's f, which means this graph, which is the graph of f, is also the graph of g prime. And now we're back in chapter 4. Right? 3, 4, I don't know. 4. We're in chapter 4. Okay. So this is the graph of g prime. G is increasing when g prime is positive, which means literally above the x-axis. G is concave down when G prime is decreasing. G double prime is negative, right? So we're looking for where G prime is positive and decreasing. Above the x-axis, but decreasing, there are two intervals, -5 to -3 and 0 to 2. Positive and decreasing. So here's the thing. That's me writing a whole bunch of stuff. Okay, so there's your intervals, increasing concave down in those intervals because G prime is positive and G prime is decreasing, or G prime is positive and G double prime is negative. Little warning, if I use G double prime in my answer, then I have to write a relationship for G double prime, right? Anything I use, I got to relate somehow. So if G prime equals F, then G double prime equals F prime. You just have to write that, and then you can use it all you want, right? So as long as you relate them, you can use them interchangeably however you want. But you got to show the relation between F and G. Okay. That is your quiz. Now we're going to work a couple of problems. A little note. So this problem right here, this is an AP problem, 2011, number 4. It's a problem very similar to this one. It's this type. But I want to show you something else instead, because we have like 6 minutes. We have time for me to show you this. So I'm going to minimize this. And I'm going to go to Schoology. I don't want any of the. Here we go. Okay, go away. Okay. I'm in Schoology. Unit 4, which is Chapter 5, Integrals. The only thing that's in your Schoology right now. And I'm under Review Materials. So there's the calculator tips sheets in case you want to look at them again. So Chapter 5, Formative Assessment. These are just some multiple choice practice problems if you want to try them. Kind of fun problems on integrals. Okay. Antiderivative review, just practicing a bunch of antiderivatives with solutions. FTC and U-sub review with solutions. Riemann sums with solutions. I think the Riemann sums might also include trapezoids in there too. All right. But then we get down to these big test reviews. These big test reviews are from a teacher I used to teach with in Georgia years ago, and they're from our old book, but they're great reviews. So they are, like the first one I know is pretty much all just integrals, like practice on U-sub and that kind of stuff. This third one starts with the kind of problem that we just did. It's not set up great, but it's all right. So g of x equals the integral from -2 to x of f of t dt. He gives you a graph, and then he asks you all kinds of questions about it, right? So then, and then there's another one, same type, bunch of questions. All right, here's some Riemann sum practice, trapezoids and rectangles. All right, and here we get into a really big calculator PVA question, which is an awesome question. So if you want some really good practice, look at that. It has L parts, right? So if you want to practice everything you'd ever need to practice on PVA, test review number 3 has like everything you could ever possibly need, right? And let me go where, how do I get out of here? Go away. Okay. And right under those reviews are solutions to all 3 of those reviews. So, okay, it's not my handwriting because it's David Yang's handwriting, but there's the solutions. There's review number 2. All right. And then here's the review number 3. Right. It's all really nicely written out. He has much neater handwriting than I do. And then like here's the whole PVA thing, like with answers and everything. So there you go. So if you want some extra practice on the word problem kind of stuff, that's a great review to help you get ready for the word problem kind of stuff. There's another test review number 4. I haven't even looked at it. I don't know what it is. It's extra stuff. tomorrow I have a Jeopardy game and I have a Kahoot. So tomorrow we'll probably do Kahoot. We might do Jeopardy. I got to look through the Jeopardy game and see if it's any good. It might be good. I think I might have written it. I have a Jeopardy account, and I subscribed years ago to this Jeopardy building website, and I made all these different Jeopardy games and just had a lot of fun with it. So I think this might be mine, but it might be student made. I gotta look at it and see. Anyway, but that's all in there for you to work on. Don't forget to do the review in WebAssign. Also, the review in WebAssign has some great practice problems, including piecewise definite integrals, right? So make sure you know how to do all of that. And tomorrow, whatever questions you have, if you don't want to play games, if you want to ask me questions, that's fine too, right? So, well, you never know, right?
I don't like how they talk.
Okay. If I could do a quick piecewise integral. So if we do the integral of f of x dx from 1 to 5, and suppose f of x equals x plus 2 for x less than 3, and equals x for x greater than, I'm going to do like nice, easy functions. Okay. All right. So the problem is this function is valid for all the x's less than 3. And this function is valid for all the x's bigger than 3, right? So what do? Since I'm going 1 to 5, I have to do the integral from 1 to 3 of that appropriate function plus the integral from 3 to 5 of that appropriate function, right? Whichever function is appropriate over those values of x. You just split it up to whatever is appropriate, and then you do the integral. Does that make sense? Yeah. So that's how you do an integral piecewise. Just got to use each function over what values of x is appropriate.
I'm just tired myself.
Oh, okay. All right, good. Any other questions? Like last minute little things that you want to ask for, because we have 2 minutes. Nothing? You're like ready to go. Like we should test tomorrow. Oh, what is FTC Part 2? FTC Part 2 is how do you evaluate a definite integral, right? FTC Part 2 says you find the antiderivative, and then you plug in the top limit minus plug in the bottom limit. That's FTC Part 2. So FTC Part 2 is saying that a definite integral is equal to the antiderivative evaluated at the top limit minus the bottom limit. Yes. All right, good. Good question. Where did my recording thing go? I love. Oh, there.